Good morning, everybody, to our IDSA webinar on the IDS Reference Architecture Model 2.0. My name is Sebastian Steinbuth, the lead architect of the International Data Spaces Association, and I'm very happy that today Jaroslav Pullmann from the Fraunhofer Institute for Applied Information Technology will talk about policy languages. This is really in the heart of the IDS, as usage policies are one of the most important aspects in our architecture. If you're going to join our webinar today, you can ask your questions afterwards in the questions and answers block. You can ask directly or write your questions in the chat, and I will read them out loud afterwards. If you join our webinar on YouTube, just comment below or come back to us via email or just give us a call. If you like this webinar, just hit the like button below. So Jaro, I'm very happy to have you here today for your talk, so please go ahead.
Thank you, Sebastian, for the introduction. And along with me, Sebastian Bader and Christian Mader, colleagues from Fraunhofer IOSB, as well have prepared or helped to prepare this presentation and are very much involved, actively involved in developing the concepts and IDS approaches behind usage control in industrial data space, along with other colleagues supporting more the enforcement layer. So let's look at the agenda. First, there will be a short general introduction into the topic. Then we will look at how policies are being specified, at the approach, how these are enforced and intended to be enforced in IDS, and then we are open for discussion. So introduction, we'll look at the concept, the central concept of data sovereignty in IDS. It will motivate an usage of, or the use of usage control, provide some background on this concept, contrast it to access control, and present its contextualization in the IDS architecture. So the core value proposition of the IDS is maintaining data sovereignty. This is just an excerpt of the reference architecture model, which said that data sovereignty is natural persons or corporate entities' capability of being entirely self-determined with regard to data, to its data. So it means rephrasing this sentence, this subject, this natural person or corporate entity should be able to govern how the data is being shared and used, and doing this in terms or explicitly stating such policies in terms of a policy language, and relying on the infrastructure provided by an industrial data space, which are, for example, the connectors, with appropriate support of usage policy enforcement to have these restrictions implemented and put in action. The means of implementing data sovereignty is the concept of the technology of usage control. Once again, rephrasing the reference architecture model, to ensure data sovereignty, the concept of data usage control provides a necessary technical mechanism. So, but let us look what it means with regard to a motivating scenario. So here, different stakeholders are displayed, which might have interests in preserving their sovereignty, or the handling of their data. For example, within such a scenario, the provider, the supplier, for example, of particular products may be asked to retain the data, for example, for at least or at most 3 days. So this would be one of the policies put on one of the stakeholders. then, for example, law enforcement agency might be requested to filter attributes of data which might be or include hints on personal identity. Energy provider, for example, must, in providing data, for example, like bills, to comply with GDPR constraints, and ask, for example, for consent of its customers in sharing and processing the data. And the data analyst, for example, is forced to apply or follow this restriction, for example, working or treating only anonymized version of data. So looking back at how usage control was defined in beginning of the somewhere around 2000, the starting point, the baseline, was the access control, the traditional access control, which mostly look at authorizations. So these are statements of permissions of subjects to perform particular operations, such as read and write and execute operations upon a target data object, digital objects. Traditional a formal model of expressing such mostly static, or those times perceived as static authorizations, were access control matrices, where the particular access rights on a file or device, so on a digital object, are treated as columns of this matrix, and result in specifying an access control list. So the type of operations which are allowed on this object. So this is the object perspective, and the individual rows identify which subjects, the subject capabilities in interacting with the system with regard to the operations they're allowed to perform on the individual resources of a system. And further baseline of the access control is a assumption of a structured model of entities like the object, and which is being accessed, and the subject, which has sort of attributes the traditional access control evaluates in order to allow or denies the operation on the object. Further, the modeling of environments of the environment was introduced, especially and later in usage control. We will look later how the usage control a model as introduced by Sandu and Park first identify the dynamicity of how access is being performed and resources are being used. So they approached or they embraced the mutability of the attributes of subject and objects as a result of the usage. So compared to the traditional access control matrix, now the static description of the attributes of the entities, now these become dynamic and change, may change in course of the usage of a resource. For example, the count of accesses of a resource might increase, or the duration of using and accessing to a resource might be persisted and used in further evaluations. These evaluations even more become dynamic. So while the access control traditionally looked only in the ensuring, on enforcing the access on prior to usage. Now, for example, as well, the evaluation, the enforcement of resource access may happen on usage time and post-access time. So the continuity of evaluating the properties and then the attributes of the subject, object, and the environment has been enriched by a continuous model, continuous evaluation. For example, then the purpose of processing has to be prior to access ensured, or particular actions have to be take place before granting access to the resource, or particular actions might happen after the usage and the access have been granted. This slide depicts what I said before, that the modern usage control based on the ABC model in fact is an extension of the traditional access control by augmenting the traditional authorization by further decision factors of the obligations. These are requirements which should or must be followed, must be fulfilled in order to grant subject access and allow usage of a particular object. So these are the obligations on the subject, which might be evaluated, as I said, pre, on, or post access. And the ABC model further adds a further decision factor, which is the considerations of the environment. So the environmental requirements should be satisfied prior or during the access. Obligations, an example, for example, for the obligation might be, as I said, the availability of a particular credit balance if accessing a commercialized resource, or this might be the agreement with a license statement by clicking the agreed button. Examples of conditions which govern the decision upon access and usage might be, for example, the load of a system, which allows access only to a particular group of customers, or the opening hours, so there's the service time, which is an independent factor compared to the properties, to the attributes of the subject and the object. The obligations are quite, there are many variations in what might comprise an obligation. There are various dimensions which might be supported. Some of these are, for example, time, where the storage for at least or at most particular amount of time might be required. Examples, the data might be, or I don't know, networking or mobile operators might be asked to store the connectivity data, the connection data, for at least 10 years for investigation purposes. The opposite might be requesting a deletion of personal data after a particular explicitly stated amount of time. Location might be as well a subject of an obligation restrictions in terms of geofencing, when actions or accesses are allowed or disallowed based on the position of the subject. Cardinality looks at the restriction of accesses based on the number of the previously happened or previous number of accesses, renderings or distributions of a resource, where, as I said, the mutability of attributes of a object and subject are of great importance. Then the presence of particular events like the revocation of a permission is of course decisive about the access and usage decisions. Then particular actions might be requested prior to allowing the use of resource, like the agreement on attributing or notifying of use of individual uses of resource, or the payment of particular amount. Then the enforcement of some restrictions which may apply, legal restrictions may request to expose data only in an encrypted format or distribute it only in an anonymized way. Then there might be, for example, an obligation to maintain an up-to-date snapshot of the data, which would require, for example, clients, consumers to refer not only to the normative published version of data. And of course, an obligation could refer to the purpose of use, restricting use of a resource to only a non-commercial scientific one. And now I will pass to Sebastian Bader to give us or introduce the policy language being developed in IDS into the context of reference architecture model, which is one of the main assets being developed in IDS.
So thank you, Jaro. I just would like to spend a few minutes now and put that into context, and especially, as you said, into the reference architecture model, which gives some basic overview of what the IDS actually is. So first of all, starting with what we call our business layer, the usage control in general, and of course, the usage policy language in particular, is the core enabler for any business model based on the industrial data space. So without usage control, as you specified, no data sovereignty is possible, therefore no business case in the IDS is even thinkable. In this context, we are talking about data users and data consumers, but also about app providers who need to specify the capabilities and the requirements of their data apps. We're also talking about the clearinghouse providers, for example, which is necessary to log or save information. All these players in the IDS have to have an understanding of the usage policy language. They have to know what the terms are, and they have to play together. And the usage policy language is exactly the carrier of information. So we have a foundation for any business process here. The functional layer is more specifying these foundation. So we are talking about functional and non-functional requirements here. We are specifying the required interfaces to understand and to exchange usage policy languages, and to enable the business processes on top of that. Process layer, information layer, and system layer are then more providing information in detail. Of course, the policy language is an information carrier. And therefore, the information layer, as you see here on this graph with a little bubble, is the main part where we will talk in detail about the language. System layer is then responsible for implementing that. So we will continue on that. So, Jan, if you could go to the next slide. Perfect. Here you see a snapshot of an architecture as specified in the IDS process layer. You see several connectors, which here are the technical implementations of the IDS interfaces or gateways. And these players need to exchange language files and information about the proper usage and allowed usages. So what we have is we exchange meta information, and the usage policy is therefore part of the meta information. So for example, here in the middle, we see that connector A, the data provider, is exchanging policy as part of its meta information, part of its data artifact descriptions to a data consumer, which is then able to understand in detail what exactly shall happen and what must not happen with this data artifact or data resource. Other players are, for example, the infrastructure components in our industrial data space, mainly the broker, which could have some self-descriptions from a connector, and this self-description would contain policies on top of offered data resources. Therefore, a connector can understand the restrictions based on offered information, offered data, and then is able to select proper resources for his further processes. Furthermore, we have app stores. In particular, here we have data apps. These data apps are used to process further information and process further data. In these terms, the data apps also need to understand our usage policy language, as they are a central cornerstone in our process of applying something like a demilitarized zone on the data consumer side. So in this part, the data provider is specifying his usage restrictions as part of a policy, in our policy language, of course. And the data app is one processor or one service which operates and, of course, has to stick to the policy language and the restricted rules provided by the data provider. Otherwise, of course, data sovereignty would not work anymore. So these players all have to understand and integrate and create languages and language files and the necessary information and stick that to the interaction patterns and exchange patterns as specified here in our process layer. On the next slide, we now take a look a little bit more on the information layer. So information layer in the IDS context has three basic parts. The most abstract one is down there on bottom left corner, where you have basic conceptual representations and diagrams on the information model and how we see and how we want to model the world. On the other end, on the top right corner, we provide implementations and code implementations to actually use the specifications and models. In between, we also have something like an intermediator, mainly based on RDF, Resource Description Framework, close to ontologies. Here we stick to RDF-OWL. And actually, our usage policy language is described in exactly this format. So we have something like here, an intermediator between humans. So the language we have here is still to some degree human readable, but it has a formal logic and a shared vocabulary with a very specified meaning. And we use that to automatically interpret our usage policies. And to have this, we have to have a strict and shared understanding on what each term and what each construct actually means. And this exactly is our usage policy language. Yeah? So we have here a shared understanding not only between the users of the IDS, but also about the data connectors. So the technically components share the understanding on the specified requirements, both on access and usage policy restrictions. And they can use that to exchange information with people, but also with components which we haven't seen before. And the other, the receiving part is then able to automatically understand what we wanted to specify without further information. So let's sum it up a bit. We have a formal language here on a shared understanding. Yeah, thank you, Yara. Perfect. Just go to the next slide. And at some point, of course, we have to put that into context. Usage control in the IDS is not only a language. We also think about how can we then execute the languages, and how can we then enforce them in detail. Therefore, you'll find a lot of information in our system layer specification. We also provide several proposing execution engines from Fraunhofer, but also from third parties. And these will then translate the usage language into their own configuration model. That can be part of the App Store, it can be part of a broker, but of course, mainly it's part of the connectors, where we have a so-called policy enforcement point, so the PEP, which you see down there, which is a central component to actually enforce policies. And to do so, each of these engines has to translate from our common shared model and vocabulary to their own unique specification and vocabulary. This is not part of the language anymore, because we want to make the language agnostic to implementations, but we specify and formulate requirements, and then in order, each provider of such an engine must translate it accordingly and must provide a translation component according to its own data model and its own enforcement model. So that's more or less how usage policy is located in the reference architecture model. If you have further questions, yeah, please ask it after the webinar, or just take a look at our reference architecture model, which is online. And by the way, Sebastian, I think I can be brave enough to announce that there will be a next version of the reference architecture model, and you will find a lot more information on usage control and our usage control language in the third iteration of our reference architecture model.
So thank you very much, Sebastian, for putting the policy language and usage control in context of the reference architecture and the individual layers of it. Thank you very much. So then we were talking about, so we introduced somehow the notion of usage control deriving from access control. We provided examples of the particular decision factors like obligations, set the policy language, the usage policy language in context of the reference architecture. Let's look at the specification. So there's an abstract policy model we shortly present, and then we look at the details of the Open Digital Rights language and W3C standard, which is used to implement it. And then to see what relation of the IDS policy language to the ODRL is, see some examples, and talk about open issues. So at the heart of the policy language, of course, a set of rules stands a set of rules which define permissions, obligations, or prohibitions of a party which apply to an asset with regard to particular actions. So this is a sort of rephrasing the UCON ABC model we saw in previous presentation. Make it more concrete, we use the rely on Open Digital Rights language defined by the W3C consortium, and this is a bit more elaborated picture where the type of policies, for example, is further specified in order to give it more concrete semantics. Then there are further features like specifying a collection of assets or collection of parties, not only being restricted to individual ones and identifiable ones, where the attributes of subject, for example, come into play. So just to summarizing, at the top of expressions of policies is the concept of policy with concrete subclasses like set of an agreement, and the implementation is an express a set of rules which are either expressing a permission, duty, or prohibition of actions upon a target resource, target asset, expressed by the assigner party to an assignee. So this is a summary of what I said. So policy, a group of rules formally stating usage agreements among parties. There are different types of policies. Set, which is not further semantically specified, it's just a statement of existence such policy of such policies. There is an assertion, which is a claim that such policies exist. There's a request, which is quite important, especially in negotiating policies, where this is a proposal of an assignee to an assigner to be given a particular usage allowance for a particular resource. There might be the opposite, the offer, which is often found, which is normally found in instances of the information model, where a particular party, the assigner, states the rules at which digital resource may be consumed, and at end of negotiation process, there's a policy of type agreement, where the granted rules which were negotiated among the parties, among the assigner and assignee, are stated in a final version. And the ticket is a type of policy where a reusable or in a sense of reusable access or grant is being assigned to the holder of the ticket. I'm not really diving into the details of the individual classes. So the rule, as was said, is just an abstract concept representing characteristics of how particular actions are to be interpreted with regard to an object, and the subject which is the policy stated for. So the action might be permitted. So this expresses the ability of party to exercise an action over the asset. It might be prohibited, which inhibits the party to exercise this action on an asset explicitly. Or, and this is the example of the obligations which were introduced previously, it might require a party and the assignee to exercise an action prior to or after or during the execution of the access and usage of their policy. Then the notion of the subject was borrowed from the access control, which is called here in this context party, which is at the superclass of entities that may undertake particular roles, like being the assigner, the contractor, or being the assignee, the contractee, and beneficiary of a contract. And if we are facing a multi-valued parties, then their particular properties, attributes, might be defined by terms of constraints. So the asset is the object in a traditional access control way, which is a resource or collection of resources that are subject of a rule. And the actions are operations which are somehow governed in terms of a rule. And the ODRL standard already defines a number of reusable instances like aggregate, annotate, anonymize, append, whatever. One needs to look at the particular semantics or definition of these actions. For example, one could imagine a rule stating the obligation to use or to distribute data only in an anonymized way. So the minimal vocabulary needed for expression of such a rule is already provided by the ODRL standard. A further important concept of ODRL is this of a constraint, which is an expression that governs and refines the applicability of a rule. For example, when, with regard to environment, we remember the environment properties are quite important in usage control, the rule applies, where they refine the action in stating its particular properties, like printing of resource is allowed only with a low resolution, might be a refined action of printing. And the constraint may allow to select members of collection assets and collection parties, where it is not clear which individual particular asset is meant or targeted by rule, but the group is filtered or is constrained or more refined by terms of a filter, for example, pointing to a required row of the party. Multiple constraints are in ODRL implicitly and connected, so this all of the restriction and constraints must apply. If more complex constraints are to be stated, then the notion of logical constraint supports the definition of logical conjunctions of such constraints, being either alternatives, being exclusive alternatives, being mandatory and connected, or being requiring the constraints to be applied in a sequence. Fine, and then finally, there's a remark of how constraints are defined or expressed. So there's a functor expression of operator which sets a so-called left operand into relation to the right operand. So let's look what the operator operand, the left operand are, because these are quite important and a bit cryptic concepts of ODRL. So the operator is a function which compares its operands. It might be, for example, the equality or comparison of values, numeric values, or the selection or checking for existence of a particular item within a collection. So these are the operator, the functions applied on operands. The left operand is a predefined name, and this is a notion which refers to an access function to attributes of the subject, object, or the environment. For example, the absolute position of the user of the subject, of the agent, would be retrieved and reasoned upon in order to decide about access and usage control policy. Likewise, the count, for example, the number of accesses would be evaluated in the same way. So the left operand is a concept, or is a there's a set of predefined contextual primitives, which make sense in a lot of scenarios, of usage control scenarios, but as we will see later, they need somehow to be interpreted by an enforcement engine, and this is where a lot of uncertainty still exists about a concrete and reliable interpretation. The right operand of a constraint is either a value list or UI, for example, reference to a resource, which might be further extended by a data type and a unit. Fine. This is an example of a but more complex agreement. So this is a statement of asserted of permitted actions and prohibited actions, which has been agreed upon between the assigner, which is the supplier, and OEM, which is the assignee. And it allows the assignee to use this particular resource, which is an access, for example, to a data service, when compliant with particular purposes, and which prohibits the usage of this data, of the same data, for other purposes. So the purposes are expressed as constraints where the left operand is already predefined. This is the reference to the purpose of use. And the right operand is a variable, which is indicated or defined by the assigner. So in this particular example, it is allowed to use the data in question for purposes of risk management or bottleneck management, whereas it is prohibited to use it for commercial purchasing or sales. And this is a more visual description of the example provided. So where it becomes more apparent, for example, the structure of a logical constraint, of a complex constraint, where the purposes are all connected. So and likewise, it makes more explicit the structure of the rule with regard to the prohibited purposes. So and then this is then the details. These are the details of expressing the constraint on the purpose. Fine. When looking at ODRL, which is our which is the main source of implementing the policy rules in IDS, we often faced type of problems which are summarized here. For example, the identification of and reference to parameterized assets. So if we are dealing with dynamically provided generated data, then it is quite awkward to specify which particular data was meant, because often referring to services subsumes or comprises a whole bunch of possibly parameterizable data. So provision of parameterized and in the identification of a parameter subset of dynamic data is not easy, or at least possible with generic ODRL tools. Then decision on persistent and consistent identity of resources, because once the resource is being submitted to the consumer, then of course the identity, which was, for example, the URI used to access the data, is gone. So then a type of persistent identities need to be given to resources in order to support enforcement on the client side. Then the actions are not further defined beyond textual documentation. I think, and this is already, this is as well felt as a weakness by the group, and which is, I think, going to be addressed in a further iterations of the ODRL standard. Then constraints, it is not that clear, for example, the set of units, and for example, might sometimes need to be extended, of course, which is very preliminary in a standard, and it is not yet clear, for example, how the status is being maintained. So these are questions to be delegated to the implementers of such a policy language. And of course, the left operands, which we saw are quite important means of interacting with the context of the evaluation, need to be more closely formally defined, and as well it should be identified which information is needed to be preserved and maintained in order to make decisions upon the contextual information. So these need to be further identified. having this overview of ODRL, the question would be, how does the IDS policy language relate to this language? So we consider the IDS policy language being the profile of ODRL. What does it mean? It extends in some parts the ODRL, the core ODRL elements by subclassing. So we still have the class of an agreement or rule, prohibition, action, or whatever. So we are still reusing the ODRL concepts within the IDS namespace. Then we further restrict the selection of supported elements based on the IDS use cases, and then select those actions, left operands, which are useful in this context. For example, in order just to look at the particular implementations, and here a restriction is needed. And sometimes we are forced to add new elements, like identify new actions, or to have more elaborated pricing models, which reflect demand on commercial exchange of data. Some of the examples and the model of the preliminary model of the policy language may be found on GitHub, and the source is given below. The last the group of slides looks after we have given an overview of the specification of policies are being specified and formalized, is looking at enforcement, where they make sense. So what the enforcement levels are, and the generic concept of enforcement. So there might be different types of enforcing, and looking at enforcement of policies. This is visible in this slide. So when talking about ODRL and the specification level policies, it was apparent that these are declarative contracts. These are quite high level, almost natural language or somehow machine readable expressions. And in order to make them technically enforceable, they need to be turned into implementation level policies, which look at the particular systems like databases being wrapped, or accesses to files being intercepted. And this is normally done by usage policy enforcement frameworks. I will present them later on. So summarizing, there's a range of enforcement levels of usage policies. There's a purely technical enforcement for some rules. There might be an implementation in terms of organizational rules, policies, and instructions. Or, for example, there might be a purely contractual enforcement of policies, and just stating a legal binding contracts as contractual regulations. Then in order to technically enforce policies, we need to somehow map them to available implementations in the IDS. So the specification level policies defined in the IDS policy language based on ODRL are being mapped to policies of policy languages of the individual frameworks like IDS and UCON, and further target environments. How does they look? How these environments look like? They were presented in a previous webinar, like the IDS framework from Fraunhofer IOSB, which is an event base, which defines or uses an event based approach, and an XML specification language. There's as well a snapshot of the interface to see just how these policies are being deployed and administered. This is the main target of the integration, the IDS policy language, into a concrete enforcement framework at the moment. The alternatives, which are more looking at the flow, the restricting the flow of data, whereas to preventing access or controlling the access to resources. And this is handled by the usage enforcement framework, Fraunhofer IOSB called UCON, refers to label-based usage control, where the labels where attributes of subjects of data are, and of course the interacting of objects and the interacting subjects are being evaluated. And there's a solution which looks merely at the provenance tracking in order to ensure, for example, in scenarios of personal data monitoring, whether it has been used and treated in accordance with GDPR and further compliance rules, where the transaction history, the data flows are being logged. Such log data is being securely stored in a distributed manner, and the data owner is given an insight into scenarios, into the contexts, how its data is being used. And this is a small concretization of a possible enforcement infrastructure in IDS. It refers to what has been presented by Sebastian. So, and it reuses the terminology of the SACML standard architecture, where the component of PEP, the policy enforcement point, is intercepting accesses to resources which are deployed or which are connected behind this PEP. The PEP is interacting with the policy decision point, which is relying on the definition of policy, on attributes of the subject in question, of the agent, and of course of the data being considered, and of course of the environment parameters, and as well the component of PXP, the policy execution point, is involved, where the manipulation of the data, or for example the execution of auxiliary actions like notification, might be performed. So there are several deployment scenarios and deployment architectures for an enforcement control enforcement framework within the IDS, with regard to the topology of the IDS, to the connectors on the provider and consumer side. And there are some open issues with regard to enforcement. For example, the transformation of the policies, where sometimes human intervention is needed, configuration is required. Then, of course, we're considering the context. This is still unclear how this is to be maintained and exported or exposed via a component like the policy information point, which is sort of the context keeper of the policy decision point. Then there's some potential for privacy conflicts, because the maintenance of contents and provision of information, like the location of a subject for geofencing, is as well subject to restrictions. So while we are trying to resolve or to support usage enforcement, usage policy enforcement, we are at the infrastructure level, for example, the context maintenance level, as well dealing with such privacy issues. And of course, for example, the processing, the sequencing of tasks in interpreting policies is sometimes unclear and not mandated by the standards. And there are often cases of conflict resolution. ODRL luckily has already some notes and explanations on how to resolve particular conflicts. Okay, so this is an excerpt of open issues we are facing when trying to make the abstract, the specification level policies implemented and enforced within the IDS. Thank you for your patience and participation. We arrived at discussion. I'm happy to answer, and my colleagues answer to your questions and maybe to discuss follow-up actions about the usage control in IDS. Thank you.
Thank you, Jaro. Thank you, Sebastian. Very impressive and absolutely interesting talk from your side. So thank you all for listening here. If you listen to us on YouTube, don't forget to like our video and comment below. For all of you who are live in this webinar today, I don't see any open questions in the chat window. Is there any question left to the audience?
Maybe there are more than a simple question which could be asked. So there are really many we could think of. Yeah. Mm-hmm.
Yes. Sorry, I was muted. Mm-hmm. Sorry, because I have a question. It was very impressive what you told today, and I'm quite happy to see that there is a language to provide rules to a system, and I'm quite sure that this works, that we can specify rules. But I think this leads to, if we have a check mark or a small check mark on this point, this leads to another task that we have to solve. And this is on the information and the decision making. We discussed recently, for example, a use case based on a health record. And maybe I want to put a usage policy, a rule on my health record that it will be locked down when I'm dead, when I'm dying. And so this might be an important rule, but then therefore we have to identify and decide when I did die and when to lock such a health record. Or if we state a rule, the purpose of the data set. For example, the data set may only be in logistics or may only be used in medical or whatever it may be. This can be a hard decision today to really decide if this purpose is really a logistics purpose or not. And so I think the decision making and the gathering the relevant information for decision making would be the next hard task we have to do. What do you think about this?
Yeah, Sebastian, thank you, definitely. So the interpretation of purpose is quite speculative at the moment. You're right. So what does comprise scientific or, I don't know, educational purpose? So it's up to be discussed. Yeah. So I think there's sort of IDS within reference architecture, or for example, within more detailed specification, should spend some words on, or within the definition of the IDS policy language, somehow nail down what is meant with a particular purpose. For example, by referencing standards, by referencing sort of regulations. Okay, and this is the point of specifying a notion of, for example, purpose, or the left operands, which are the means of introducing contextual knowledge into the policy enforcement, are likewise subject to interpretation and definition. And of course, on the other side, there's the enforcement. How the observation of a particular purpose and the re-evaluation, we know that this aspect has been introduced in by the usage control. So the continuous re-evaluation of the state of the world, how this is to be applied, for example, to purposes. I think these are exactly the questions which a community of applied usage control should look at. I think we are quite at the beginning. So we were looking at the implementations of ODRL, and they mostly focus on the definition of rules. So they are mostly editors, validators, but not enforcement. And I was so happy at the last winter days, the meeting organized by IDSA, to see implementation, a first implementation within context of fireware on dynamic data, which was presented by Joaquin and his colleagues. So this is one of the paths, one of the tracks I would like to collaborate and develop further our notion of enforcing policies, for example. So Joaquin, what is your status, or what is your meaning, or what is your idea on implementing, enforcing policies? So which difficulties were you facing?
Yes, our approach has been to develop a way to interconnect this to real big data processors. Since our background is from formal protocol specification and also conformal testing, it's quite similar. We identify in this data processing some of the events that they're producing. On the other hand, we have the specific description of the data policy in the abstract language. So what we did is transform this abstract specification into a set of behaviors that we detect that are the one we allow or we have to enforce. Enforce means probably stop the execution of the engine. Right now, we have just made a proof of concept and we are generalizing it. So we develop some extension also from the ODRL. We did by hand, in this case, a transformation into some kind of process algebra where we define how this abstract specification gets into more complex things to allow auto-forbidden things that happens in implementation. And later we make it a transformation right now by hand, but in the past we have done automatically in the contents of conformal testing to automata that just is verifying that the execution engine is doing properly things. So our approach is go on with this approach. We think it's quite nice because we haven't seen anything like this in the literature. So we think that it's a very promising, and I think that perfectly match with the architecture that you have already described. So for us, will be perfect to collaborate and try to, some small details, perhaps match your architecture and your definition. And then we can collaborate also on the definition of the extensions on ODRL, because ODRL is too oriented for media, and we have to develop a completely new set of entities and vocabularies. This is something that need to be done, and we have some ideas, and we can collaborate on this. So I think we can collaborate on architecture, on the definition of the language, and going on with the approach that we are having with this way of policies.
Yeah, thank you very much. Yeah, so I see there are a lot of overlaps in terms of specification of, for example, then the details of. I know you were applying it on event data, so which is not yet in our focus at the moment. So where we more look at assets, at static assets, and where, as I mentioned, for example, when looking at parameterized interfaces, it's becoming really ugly to specify the identity of such data and specify really what is the target of a rule. Yeah. So these are, I think, we are about transiting a bit abstract ODRL applications to very concrete real-world examples and see how to deal with them in collaboration as well with the group. So we intend to more closely provide them feedback and collaborate with the WC group as well. Thank you a lot.
Yeah, and what I would also like to emphasize is, as you said before, Jaro, to focus on real-world scenarios, because of course, and as I'm a computer scientist, I love those discussions on architecture and how to enforce such rules, and also how to specify those rules. But what I see as not a problem, but a challenge maybe, that we have to tackle it down to the real world's needs. Of course, in such a language, one could express everything, but we have to find out what are really the most important rules that are really needed, and what do we have to express really that has to be enforced by technology later on, and what are rules that may be necessary and also important, but they cannot be enforced by technology at all, or in a few years only, or whatever this may be. But we have to really tackle down what are the real pain points of the real world scenarios that we do have to solve first, and to really specify what this language should look like and how it could be used.
Yeah, and I think the ODRL group is heading towards this direction. So there's a preliminary work on best practices where exactly a small real-world examples are laid down and formalized in ODRL. And then the next step is to look at what the requirements are on implementing and enforcement or enforcing such scenarios and examples. Thanks. Mm-hmm.
So, any other things for today? So, if you want to raise a question and we're muted like I was before, maybe you can get a second try now. Otherwise, I would say again, thank you, especially Sebastian and Jaro. Indeed, very interesting. Thanks for everybody who was listening today and was contributing today inside the discussion. Thank you so much. And from my side, I would say have a great Christmas time and hope to see you and work with you together in the next year.
Yeah, thank you very much to your participation, and have a nice Christmas time. Happy New Year. Then talk to you soon. Bye-bye.
Bye-bye. Happy Christmas.
Bye-bye.
Happy Christmas, Happy New Year. Bye.
Bye-bye.